And finally, the last question, right? It says write this sum, it's two pieces, write this as a fraction in simplest terms. Write this as a fraction in simplest terms. I've made it a little bit larger. It was 5 over a plus a over b. Look, before we tackle this, I want to review with you how we would have handled something like this if we were dealing with just, you know, numbers. So let's take for example 3/5 and add to that 2/3. Okay. Now I can't combine these because the first collection they're fifths. There's three of them and they're fifths. And the next part they're thirds. They're not like terms. I can't just put them together, right? They're fractions with not common denominators. Fifths and thirds, I have to figure out what they are together. Well, as I look at my denominators, I can say, well, this first one, this one with the 5 in the denominator, if it had a 3 in its denominator, it would start to look a lot more like this one, right? They would have at least the 3 in common. So what we do is I'm going to introduce a 3 in that denominator, and to not change the value, I'm multiplying this by 3 over 3, right? Again, it's like a giant 1 in reverse. When I multiply by 1, I'm not changing the value of anything. So that fraction is going to take on a new appearance based on that. This other one, it needs a 5, right? If it had a 5 in the denominator, oh, wouldn't it look a lot like its neighbor? So I'm again, same thing, I'm introducing this giant 1, so I'm multiplying 2/3 by 1, but the value of one I've selected to multiply will create this situation where now these are both 15ths, right? They're now not fifths and thirds, but they have this name in common. They're 15ths. 15ths. And I'm just going to write it as 3 times 5, but you can see that they're the same. They're 15ths. In my numerator, now I have a 3 times a 3, and then plus a 2 times a 5. Now, absolutely you can do arithmetic on that, and you can take it and reduce it and do other things. But I want to leave it there so that you can see the pattern and see how really, whoops, at its heart, this problem is fairly straightforward that we're doing here. What I'm going to do is, I've got 5 a's, 5/8, whatever, 5 over a plus a over b. I'm going to begin by introducing b into this first fraction's denominator, right? So I'm going to write this, I'm going to multiply it by b over b. So now I've got a BA in this denominator. And on the other side, I'm going to introduce this fraction, A over A. So the beauty of this is in that one step, look what my common denominator is, right? If I wrote these out, this is now B times A. Just like that, done. Just like this was 3 times 5, this has B times A, this has B times A. My common denominator is B times A. In the numerator, what do I have? I have B times 5, which we would probably more customarily write as 5b, right? B times 5 or 5b. And then plus AA. AA, what is A times A, right? What is AA? Well, we can write it using exponential notation. That's a to the second power. So this is it. We're done. You don't have to reduce it. You don't have to simplify it. There we go. It's 5b plus a squared all over b times a. And that's the answer we're looking for in question 13 or a question like that.